This series of videos demonstrates the step-by-step exercises which are included in each Parabuild installation, including the free trial version. In this exercise, we'll draw a beam splice connection. From the main connection menu, click on the splice icon. Then, following the command line prompts, first select the beam on the left, then the beam on the right. And from the selection window, double-click on the beam splice icon and press Enter to confirm. Then, close the dialog. Next, click on the icon Assembly Part Selection. And if Assembly Selection Active appears in the command line, then press the button again to show Single Object Selection, enabling us to select a single object from the assembly. Then open the View Manager and click on the Isolate button. Then select the beam on the left and press Enter to confirm. Next, select the one beam that's now visible, and you'll see the grip is shown at the end of the profile. Move the cursor to above the grip and click on the left mouse button. Then move the cursor to the left and the beam will be seen to shorten. If the beam doesn't shorten in a straight line, press the function key F8 to activate the Ortho Mode. Now enter a value of 1200 and press Enter to confirm the stretch distance. Then from the View Manager, click on the Restore Visibility lamp to restore the drawing. The splice connection is unlike other connections in that its location is not the intersection between two base profiles, because the two profiles are parallel. That's why the end of the profile selected first is used as the placement point of the plates of the connection. The second base profile is then either shortened or lengthened. In this exercise, we'll draw and modify a beam to column connection using a multiple selection, and then we'll save and reuse the modified connection macro. From the main connection menu, click on the beam to continuing column icon, and then following the command line prompts, first select the front middle column and then the beam on the left. From the selection window, double-click the connection, tube end plate and flange plate. Before we confirm the selection, we'll continue and draw the same connection at other locations. So, select the front middle column again and then the beam on the right. Then select the back middle column and the beam on the left, and then select the same column again with the beam on the right. Press Enter to confirm, opening the Edit dialog. We could have used the Propagate or Smart Copy functions to create the three macro copies, but here we want to demonstrate the multiple selection method, which, as you'll see, when modifications are made to the connection, they'll simultaneously apply to all open macros. We'll show this now when we modify the dimensions of the end plate. Change the top and bottom edge distances to both read 50 and the left and right to read 25. If you didn't consistently select the columns and beams on the same edges, it may be found that connections are rotated through 90 degrees, causing the top and side distances to be switched. In this case, it's not a major issue because the beams are square and thus symmetrical, so we can simply edit the dimensions. However, if the connections are non-symmetrical, then it could mean checking and correcting each connection individually. So, to avoid these complications, remember that it's good practice to select the profiles consistently. For example, in this case, always select the bottom of the beam and the inward facing side of the column. Next, activate the flange plate tab and modify the top and bottom dimensions to read 50. Then activate the bolts tab and modify the number of vertical bolts to 2 and the number of horizontal bolts to 1. If you then rotate the view and zoom in on the connection, you will see that the bolts are not centered, because in most connections the bolts are drawn at the start position of the bolt pattern. To rectify this, click on the button at the center of the bolt pattern, and in the bolt settings dialog, modify the bolt placement for remainders on the right hand side to centered, then press close, and finally close the edit dialog. Now we'll look at a variation of the beam to column connection. Click on the beam to continuing column icon from the main connection menu and select the front left rafter. Then select the beam or collar tie located between the rafter and the column. From the options window, double click the connection tube end plate 7 and press enter to confirm. Modify the top and bottom distances to read 70, and then zoom in to the new connection and select the rafter. Here you can see there are no bolt holes in the rafter because the bolts are located too close to the web and they penetrate the web flange rounding. To rectify this, we must move the bolts. Bolts colliding in this way are shown in red to alert you of a possible clash or interference. So we'll modify the left distance to read 20 and then close the macro dialog. We'll now look at what can be done when we select the wrong connection. Click on the purling brackets icon from the main connection menu and select the front left rafter near the bottom side. Then select the hollow section beam between the front rafters, also near the bottom side. You'll see that the No Macro Found window will then show, because the connection we wanted was chosen incorrectly. But we can continue by clicking on the Search Library button, which will search Parabuild's connection library and propose viable alternatives. From this window, double-click the Tube End Plate and Flange Plate option and press Enter to confirm. Click on the Front View of the Current Part button at the bottom of the Edit dialog to view the front of the plates, and then modify the top and bottom distances to read 60. Activate the switch next to the left distance to make it responsive, and change the width of the end plate to 80. Then activate the Flange Plate tab and modify the top and bottom distances to read 60. And finally, activate the Bolts tab and modify the number of vertical bolts to 2 and the number of horizontal bolts to 1. Click on the button at the center of the bolt pattern, and from the bolt pattern settings dialog, modify the bolt placement for remainders on the right hand side to center, then close the dialog. We will now store the values of the connection with a view to reusing them. Click on the Save Settings button at the bottom of the dialog, and then enter a name and click on Save. Then close the Edit dialog. We'll now reuse the saved connection settings. Click on the beam to continuing column icon from the main connection menu and select the middle left rafter. Then select the other beam which is still to be connected. From the options window, double click the connection, tube end plate and flange plate and press enter to confirm. Click on the Load Settings button at the bottom of the dialog, and from the options window select the file we just saved and click Open. The values of all the dialogs tabs are now applied to all the macros currently being reviewed. The parameter file we saved will be stored in the library of Parabuild, so if you use the shared library on the network or a cloud drive, then your colleagues will have access to the same parameter files. Finally, click on the Propagate button to copy the connection to all other profiles. In this exercise, we'll look at propagating the values of a connection. Move the mouse cursor to above one of the bolts, and then double click with the left mouse button, opening the Macro Edit dialog. In the End Plate tab, change the width of the plate to 130. Then activate the Bolts tab and change the number of bolts to 2. Then click on the drop down arrow at the bottom of the dialog and select Propagate Values. If you now zoom out you will see that the modification has been applied to all the macros. The top of the macro dialog box now mentions there are 20 current macros. At the end of each propagate operation, the new or modified macros are opened, so that you know how many were created or modified. There are other exercises with each Parabuild installation, and if you'd like to try these yourself, there's a free Parabuild trial available on our website.